So a tube is being stretched while maintaining its cylindrical shape. The height, so you got a tube, and it's in the shape of a cylinder. Okay, the height is increasing at a rate of 2 millimeters per second. So you've got this tube. It's a cylinder, so it's going to look something like this. Okay. The height is increasing at a rate of 2 millimeters per second. At that instant, that the radius is 6 millimeters. Now, what do you know about the radius for a cylinder? If you look at a cylinder, what do you know about the radius? No matter what's going to happen when you stretch this tube? Is the radius changing? Yeah, so you're going to change the radius and you're going to change the height. Okay, so the volume is increasing at a rate of 96 cubic millimeters per second. Which of the following statements about surface area of the tube at that instant, where volume is of the cylinder is this, radius is this, yada, yada, yada. The surface area of a cylinder, not including the top and bottom, is 2 pi r h. All right, so let's see here. What the heck we got going on? This is like it's like a alphabet soup here. All right, so we have, the goal is to find dsdt. Okay, it says the surface area of a cylinder, not including the top and bottom. They said, which of the following statements about the surface area, so that's how we knew we wanted to work with surface area, of the tube is true at this instant. Okay, so we have S is equal to 2 pi times H. Agreed? Okay, so that, or 2 pi RH. And if you did not know that, if you think about a cylinder, to find the surface area of the cylinder, what you would do is you would take the circumference, which is 2 pi r of one of the tops, right? And then multiply it by the height, and that would give you the surface area. But that would not include what? What would that not include? That would just be the surface area of what? It's kind of like if you had like you get a can of like vegetables at the grocery store, and just think of the soup label or the label around the can. Okay, that's the surface area we're actually finding. So when they say the surface area not including the top and bottom, so all this is doing, it's taking the circumference of the circle, so you're taking the distance around the circle, multiplying it by the height, and that's just giving you the surface area around the soup can, not including the top and bottom. So that's what that's saying, okay? All right, so we've got that right there is the formula. They want you to find the rate of change for this. They tell you the rate of change for volume, I believe. Is that correct? Yeah. They tell you volume's increasing at a rate of 96. So what I'm going to have to do is I'm going to have to take my volume formula. This is actually pretty interesting. You're going to need to find your volume formula, pi r squared h. This is actually pretty involved. They tell you the rate of change for volume. They tell you the rate of change for height. You're going to have to find the rate of change for radius, so that when I go to the surface area formula, I know that rate of change for radius. So it's actually, you have to do two kind of related rate things here. So we're going to have to find, and the nice thing is volume is changing. As you stretch this tube, the height's going to change and the radius is going to shrink as you stretch. Think about stretching something out, elongating it. That thing's going to shrink this way and it's going to elongate this way. So the radius is actually going to be shrinking as the height's getting larger as you stretch this tube, okay? And I don't know what kind of tube it is, okay? It just, somehow it's getting stretched. It's somehow able to be stretched. So it's probably not metal. It's probably some kind of plastic or something that you're able actually to stretch. So we're going to have, here we go. We'll have dV/dt is equal to pi, and I'm going to just leave that pi out front. So I'm going to have the derivative of this. What am I going to have to use? Product rule. So you're going to have 2r times dr dt times h plus r squared times dh dt. Now I can plug in what I know. I happen to know the volume's changing at a rate of 96 cubic millimeters per second. So that's your 96. Is it just 96 or 96 pi? 96 pi. That'll be nice because then I can get rid of the what? The pi's. Okay. And it tells us at the instant, we want to know when. We got to have the when component. When it's a radius of 6 millimeters. So we know what R is. So we know that R is 6. And then we got dr dt times h. Ooh, interesting. Do I know what h is? Did they tell me what h is at that instant? I don't see h, do you?
It gives you dH dt.
I know dH dt. Interesting. Plus r squared. What's r? 6 squared times dr dt.
dH dt?
Huh?
Isn't it dH dt?
Or dH dt, sorry. I don't know h, though. Do I? I do know dH dt. What is dH dt? 2. So I do know that. Okay, the interesting thing here is I don't know h, and I don't think they give you the original dimensions of the cylinder, do they? So I can't do a similar triangle in the cylinder. So I can't do this. I don't know the original dimensions of the cylinder, so I can't figure out based on that what that's going to be. So let's just solve this, see what happens. First of all, can I get rid of the pi's? The pi's will cancel. So what we'll end up with is this right here. It'll be 96 is equal to, I'm going to have, it looks like 12. We don't know dr dt, so we're going to have 12 dr dt times h plus, this will be 36 times 2, which is 72. Is that correct? And then if I subtract 72, that'll give me what? 24. So I have 24 is equal to 12 dr dt h, which means dr dt h is going to be equal to what? Dr dt h times h is going to be equal to 2. That's interesting, okay? All right. So now I go to my surface area formula. I bet somehow I'm just going to be able to plug this in. I bet somehow I'm just going to be able to plug this in when I take the derivative of this surface area formula. So we're going to have ds dt, so I'm not going to freak out. We're going to have 2 pi. Okay, now we're going to have the derivative of r times h. Okay, so that'll be r times dh dt, agreed? Plus, did I do that wrong? I usually do what? The derivative of r first. All right, derivative of r first. So let's go dr dt times what? H plus r times dh dt. Looky there. Do we know dr dt times h? Yep, what was it? 2. So we've got, this is 2 pi. 2 plus, do we know r? We still know r. That was what? 6. Do we know dh dt? That was 2. So that's going to be 14. So I believe we're going to get 14 times 2 pi, which would be 28 pi. And this is ds dt. This is surface area, so I know it's going to be square units per time. So it's going to be square millimeters. So it would be square millimeters per second. There it is, 28 pi square millimeters. The answer is A. That was pretty tough, actually. It's not one we've done before. We haven't done something like that where you actually don't have a way to get rid of one of the variables and you just have to trust you're doing it right. So that was a little tricky. All right, number 2, a particle moves on the hyperbola xy equals 18 for t greater than or equal to 0 seconds. At a certain instance, when y is equal to 6 and dy dt equals to 8, which of the following is true about x at this instant? This one's going to be pretty easy. So you already have your xy is equal to 18. You know dy dt is equal to 8, and that y is equal to 6 at a certain instant. So you would be able to figure out what x is at that instant, could you not? If you know what y is at that instant, could you figure out x? Yeah, if you put in 6 for y, what would x equal? 3. So you've got also, you know what x is. Now, I'm just going to take the derivative of this with respect to time, use product rule. So it'll be dx, it'll be 1 dx dt times y plus x times 1 times dy dt. Derivative of y is just 1 dy dt equals 0. I can plug in what I know. I know that y is equal to 6. I don't know dx dt, so I have 6 because y is 6. So I have 6 dx dt is plus x, which is 3. Dy dt is 8, which is equal to 0. So then I'll get dx dt. This one's an easy one. Dx dt is going to equal negative 24 over 6, which gives me what? Negative 4. So I know x is decreasing by 4 units per second. So the answer is also A here. That one's pretty straightforward. Look at this wild thing. I don't think they'd have you draw this one on your own. Okay, the figure above shows a Ferris wheel with a radius of 5 as Jalen, who is at eye level from the point 0, watches his friend Ashante ride in one of the cars as the wheel turns. Let Z denote the distance from Jalen to Ashanti's car. The diagram for the center of the Ferris wheel is 12,7, and the position of Ashanti's car at the point XY. Okay, if x and y are functions of time, what is the rate of change for z when x equals 15 and y equals 11, and dx dt is equal to, so dx dt is equal to 1. The equation of the circle, so they gave you the equation because they probably wouldn't expect you to know the equation of the circle off the top of your head because that's been since geometry and pre-calc. I would expect you to know it, but I am going to go over the equation of a circle. We did it early in the year with that Algebra Gateway review. But it's just the center. It's just x minus h. The center's 12,7, so it'll be x minus 12, quantity squared, plus the y position's at 7, so it's y minus 7 squared. You always put it as in the opposite because they're both squared, equals radius squared. The radius, do we know what the radius is of that circle? Do you know what the radius of the circle is? Well, let's see, could we find the radius of the circle?
It says at the top.
Oh, it does say the radius is 5? Where is it at?
Right.
All right there. The radius is 5, so that'd be 25. There we go. We have our equation. So all we have to do is we want to know the position. All right, it says we want to know what is the rate of change of z, okay, okay, in relationship to this. This one's kind of tough. This is actually a really, really challenging problem. So we've got our equation. All right, so let's take the derivative with respect to time, okay? And I want to figure out, z is going to be an equation. I'm going to have to figure out an equation for z here in a second. Well, z, if I want to know the distance from that point right here, I'd have to have what kind of a triangle? I'd have a right triangle, okay? So we're going to have to think about that. So you'd have your x distance. This right here is just going to be x. But then your y distance, it's going to actually be up to, okay? So the y distance actually is not y. It's actually y what? Minus 2. And then you have your distance z. So your z equation is actually going to be x squared plus y minus 2 squared is equal to z squared. So we want to figure out the distance it's changing in terms of z. So I can figure that out. So we're going to have, there's going to be a reason that I need this other equation though. Okay. Probably because I don't know, did they give us both dx dt and dy dt or just one of them? They just gave us dx dt, so we're going to have to find dy dt to be able to figure out dz dt. So you're going to have to do the implicit differentiation on both of these, knowing that I want to know dz dt. The goal eventually is to find dz dt when, so I want to do this one when x is equal to 15 and y is equal to what? 11, okay? And I can find z because I have my equation. So if you want to find z right now, you could actually plug into this equation and figure out z. So what would it be? 15 squared plus, it'd be 11 minus 2, which is 9 squared, is equal to z squared. So that would be 225 plus 81 is equal to z squared. Somebody tell me what 225 plus 81 is. What's 225 plus 81?
306.
So it'd be the square root of 306. Okay, I believe for z. Is that correct? Square root of 306? I feel like that's not right.
316.
Huh?
316. Oh,
Is
wait, no, I did 91, sorry.
Is it 81? Yep. I think I did that right. Is that correct?
Yeah.
Okay. It said when x is 15 and a lot y. Yeah, so we're going to go with it. All right, so then we're going to have to find the derivative of this. It'll be x squared plus y minus 2 squared is equal to z squared. Okay, and I could go ahead and if you want to take the square root of both sides, you could. Or you can do that later. It's up to you. Okay, I'm going to do it at derivative right now. So it'll be 2x dx dt plus 2 times y minus 2 to the first power times dy dt is equal to 2z. Let's write that better. It'd be 2z dz dt. Is that correct? What can I do with those 2's? You could just divide all those 2's off. Okay? We know what x is. What's x? Yeah, x is 15, so we're going to have 15. Do we know dx dt?
Yeah,
1 plus, do we know what y is? 11, so that'll be 9 dy dt. We don't know dy dt. We'll have to go back and find that. Equals z. Do we know z? Square root of 306, and then dz dt is what we're looking for. So the only thing we're missing is dy dt. So that's why I need to go back to this other equation. I need to go back to this other equation and figure out what dy dt is. So you would have to go over here and do a related rate for this one as well. So you're going to have 2 times x minus 12 times dx dt. So again, this is kind of like that first one. It's pretty involved. You have to use 2 different equations. And then you got 2 times y minus 7 times dy dt is equal to what? 0. And that's nice because that's the radius squared, and the radius of the Ferris wheel never changes. That's why we're allowed to plug in that 5 for the radius, because the radius of the Ferris wheel stays 5. 5 what? What is it, 5 meters? This is small Ferris wheel. It's not very big. Okay. And then you can plug in your x and y and your dx dt, and you can figure out what dy dt is, and then you're good. So what is x? What was it, 15? So that'd be 2 times 3, and then dx dt is 1 plus 2 times y. Y was what? 11. So that'll be a 4, and then we can find dy dt equals 0. So it'd be 6 plus 8 dy dt is equal to 0. So you end up with dy dt is going to be equal to negative 6 over 8, which reduces to what? Negative 3/4. That's what I can plug back in for dy dt over here. So I can take that negative 3/4 now, plug it in over here. So here we're going to have 15 plus 9 times negative 3/4 equal to the square root of 306 dz dt. All right, 9 times 3/4, that's going to give me, that's going to be a mess. What is that? Well, I think this is a calculator problem because, oh no, they don't. Look at that answer. It's flipping awful. Did they give you a decimal? Oh, there's a calculator. So we'll be able to do this. So everybody just take 15 plus 9 times negative 3/4 divided by the square root of 306. I'm praying we did the square root of 306 correctly. And tell me what you get. Hopefully it's 0.47. So you'll take 15 plus 9 times negative 3/4, take that answer, divide by the square root of 306, and tell me what we get. There it is, 0.47. The answer is C. So the nice thing is, you would have, like, they've got this exact answer, but I don't care about that exact answer. They said you could use a calculator, so just do the decimal answer. Yeah, so moving away, so since it's positive, that distance is getting bigger. So the cart at that moment must be at the point in the circle where it's actually moving away from it. So it's probably swinging back this way. So if you think of it, if he's standing, if you go back to the diagram, because there's points where he's going to actually be coming towards them, but he's probably at the point where he's on this part of the swing, where he's moving away, like this half of the circle. And then you get to a point where the other half of the circle you're moving towards. Yeah. So because it's positive. Are you glad you came this morning for this? These are tough. They kind of go through the same thing on these now. Okay? So let's see if we can do a little bit better. It's a piece of rubber tubing. Maintains, at the instance, the radius is 2 millimeters and the height is 20 millimeters. The inner radius is decreasing at a rate of 0.1 millimeters per second, and the height is increasing at 3 millimeters per second. Oh, this one's not as bad. This one's way easier. Okay, which of the following statements about the volume of the two is true at that instant? So this is just a simple related rate one that we're used to. And they give you everything. So you've got volume is equal to pi r squared times what? H. So let's do the derivative of it. What would it be? So it'd be dv dt. What would you do with the pi? Leave it out front. And then we're just going to have the derivative of r squared is 2r times dr dt times h plus r squared times dh dt. And I believe they give you everything, don't they? Okay, they want you to find the rate of the volume. It says which of the following statements is true about the volume of the tube at that instant. So we're obviously finding the rate of change for the volume. I believe they give you everything you need. So dv dt is what we're looking for. We've got pi. I think they gave you the radius. What's the radius of the tube? What is it? 2? Yep, the radius is 2 and the height is 20. So here we go. The radius is 2. And I think they give you the rate of change for the radius. What did they say the rate of change? The inner radius is decreasing at what? 0.1 millimeters. Okay, so we've got 0.1. So it's decreasing. So what do you have to put in? A negative. And then we know H. What's H? 20. Is that correct? It's H 20. And then they tell us R. We know what R is. It was 2, so 2 squared. And then they told us dH dt. What was dH dt? Positive 3. How do we know that's positive 3? Because they say it's increasing. Okay? And so then we just type all this in and figure out the answer. So this would be 4 times 20, which is 40, right?
Times 20? 80.
Oh, yeah, 80. What am I smoking? All right, times negative 0.1, which will make it what? Negative 8 plus, because that just moves the decimal over. And then we got 4 times 3 is 12. So, and then negative 8 plus 12 is 4, so it'd be 4 pi. So, and it's positive, so it's increasing. And it's 4 pi cubic millimeters per second because it's volume. I can always check my units at the very end. I know volume's always cubic units. Area is always square units, and length is always just units. So then that answer has to be A. A lot of answer A's here. Okay. This one's going to be a pretty easy one again. You got xy is equal to 15. We'll just do it. So you're going to have 1 dx dt times y plus x times 1 times dy dt. You don't have to put those ones. I don't know why I'm even doing that. It's equal to 0. And then you just plug in what you know. At a certain instance, they say x is equal to 3, dx dt is equal to 6. Which of the following is true about y at that instant? We would need to know, as x is equal to 3, we would want to know what y is. So when x is equal to 3, what does y equal? 5. Yeah, y would equal 5. Because you can just go plug 3 into the OG, the original equation. So we're going to have dx dt is 6, y is 5, plus x is 3. We're trying to figure out dy dt equals 0. So I'm going to end up with, looks like dy dt is going to equal negative 30 over 3, which is negative 10. And this is going to be units per second. So it's negative, it's decreasing, so the answer is C. No. 10. Yeah, not 5. I just looked for decreasing. Sorry. A lot of A's. Let's just say number 6 is A. But it's not. Of course it's not. All right, you got a model car traveling around a circular track. Let Z denote the distance between the model car at a fixed point 20 feet to the left of the center of the circular track. The diagram above, they would draw. I mean, this is hard enough. They would make a diagram for you. Okay? So they've got, let Z denote the distance between the model car to a fixed point that is 20 feet to the left of the center of the circular track. So here's the center of the circular track. So that's the center, 20, 0. So you can write your equation. So when you go to this, you can say, oh, it's going to be x minus 20 squared plus y minus 0 squared is equal to r squared. What's the radius? What they say the radius of that circle was? 5 feet, so it'd be 25 again. So you'd have x minus 20 squared plus y squared is equal to 25. Okay? The diagram above shows blah, 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 the position of the car. Let Z be the distance from the line segment to the point XY, so you're going to have to do Pythagorean theorem again. Now this one's easy because it's just going to be x squared plus y squared equals what? Z squared. So that equation will be easy this time. So I'll do that one in blue. So the distance from the person or a fixed point from the car on the racetrack is just x squared plus y squared equals z squared. Let x and y be functions in time. We want to find the rate of change of z when x is equal to 23 and y is equal to 4 and dx dt is equal to 2. You're probably going to have to find dy dt, so it's inevitable. You're going to have to do the derivative of that first to find your dy dt. So you're going to have 2 times x minus 20 to the first power times dx dt plus 2y times dy dt is equal to 0, and I can use that to find my dy dt. Okay, what was x? It's 23, so 23 minus 20 would be 3. dx dt, what's dx dt? 2. 2 plus 2y, y is 4, and then we can find dy dt. And then we can go back and find dz dt. So this is going to be 12, is that correct? 12, move the 12 over, so dy dt is going to be equal to negative 12 over what? 8, which will reduce to negative 3/2. Is that right? Okay, so we have that. Now you can go over here and do your other equation for the actual distance from the point 20 feet away from the circle. So you got 2x times dx dt. You better be glad you came in for this, because if they made these kind of problems, I would not be surprised you see one of these on the AP exam. I've never seen these types. Every year they try and give you a type you've never seen. So this is a new one I've not seen. Now, will they have some of the ones we've done? Oh, yeah, every year. But they could have one of these weird ones. Like I said, there's always something I can't predict. Okay? We get 2z dz dt. What can I do with those 2's again? Cross them off. Boom, boom, boom. Do we know x?
23.
X was 23. Do we know dz dt? Or dx dt? 2. We know y. What was y? 4. And we know dy dt now because we found it over here. It's negative 3/2. Z. Do we know z? No, but can you find z? You just plug your 23 and 4 in here to find your z. So you're going to have 23 squared plus 4 squared is equal to z squared. And somebody's going to have to help me. What's 23 squared plus 4 squared and the square root of that? So do 23 squared plus 4 squared and then take the square root. What does that give you, the square root? Or does it come out nice? I doubt it's going to come out nice.
Square root of 545.
Square at 545. Oh, that's ugly. But it's a calculator problem. So we're going to have square at 545. dz dt. So then your answer is going to be 23 times 2, which is 46, plus, or actually minus minus, I'll go to 8:30. I'll go to 8:30 to help you guys get this done. If you got to go somewhere, that's fine, though. 2 goes into 4 2 times. That'll be 6, right? Is that correct? So it's going to be 40 divided by, so dz dt is just going to end up being 40 divided by the square root of 545. And if you type that in, what do you get for dz dt?
1.7.
So approximately 1.7 something. So the answer is, and it's positive, so it's increasing. So it's moving away because the distance is increasing. So the answer is B. And it does have the 1.7. Okay, definitely a pretty tough AP classroom. I think L'Hôpital's rule and the other one's going to be easy. Okay, I'll do the, which one do you want me to do? Do you have a preference? Because some of you might already have some of this done. I only have some. You don't have a preference? You want to do the approximating? This is going to be pretty easy. The approximating's easy. Okay. Let f be a function such that you have the point xy on the graph of f. The slope is given by this. So they already gave you the derivative. So remember when you do linear approximation, you're just going to do a tangent line. So you need a point and a what? And then you just use that to approximate. It's that easy. So the graph passes through the point 1, 2, and it's concave down. So they might want to know if it's concave down, is it going to over or underestimate? It's going to overestimate. So we can go ahead and just cross out the ones that say under. Just right there, right out of the gate. Because it's concave down. And your tangent line is going to lie above. From the interval from 1 to 1.5, let k be the approximation found at 1.2, found by using local linear approximation at x equals 1. Well, I need to write the equation for the tangent line first. Do we have the point? Do we have the slope? Can you find the slope? Plug it into your derivative. dy dx at the point 1, 2 is equal to, all right, they've got my derivative as y squared minus x. There's actually an x and a y in it, so you need to plug in the y and the x to get the derivative. So y is 2, so it'd be 2 squared minus 1, which is going to be 4 minus 1 is 3. So there's your slope of your tangent line. So now I can write my equation. Y minus 2 is equal to 3 times the quantity x minus 1. And then I can plug in 1.2 and find my linear approximation. Now, what I've kind of trained you to do is go ahead and solve for y and call it L of x. It doesn't matter on the multiple choice if you do that. Just solve for y. So it'll be 3 times x minus 1 plus 2, and then just plug it in. So you're going to have 3 times 1.2 minus 1. This will be non-calculator. So you're going to have to multiply a little bit of decimals. So what's 1.2 minus 1? 0.2. Here's how you multiply decimals. Multiply the numbers without the decimal. What's 3 times 2? And then count how many decimal places there are in the multiplication. There's only one thing that has a decimal. So there's only one decimal point. So if the 3 times 2 is 6, just put one decimal point back in, so it's 0.6. So it'd be 0.6 plus 2. The answer is 2.6. That easy? So the answer would be what? So overestimate, the answer is C. Okay? Is that okay? I'm assuming I don't have the answer key for this one up, so we're just going to assume I'm right. This one will be really easy. It says selected values of the derivative. So the derivative selected values are given, and we know that g of 4 is equal to 12. What's the approximation for 4.2? Same thing. So we want it 4. The derivative at 4 is what? So we know the derivative. We know the derivative at 4. G prime of 4 is 2.2. So there's my slope of my tangent line. We also know the point. G of 4 is equal to 12. So here's my point. So we know my point and my slope. So it'll be y minus 12 equals 2.2 times x minus 4. I want to estimate the derivative. See ya. I want to estimate the derivative at 4.2. So it'd be y minus, you can go ahead and solve for y. You don't even have to call it L of x either. I don't give a rip. 2.2, it'd be 4.2 minus 4 plus 12. So that's going to be 2.2 times 0.2. Is that correct? All right, now what's 22 times 2?
44.
How many decimal places are there, though, this time? No. There's 2 total. You've got 1 here and you've got 1 here. Do you see that? No, sorry. That's 0.2. My fault. So you got 2.2 times 0.2. So you get 44, but there's 2 decimal places, so it'll be what? 0.44 plus 12. 12.44 is the answer. And this one doesn't tell you if the under and overestimating. Next one, g of 3 is equal to 2. G prime of 3 is equal to negative 3/4. We can write the equation real quick. Y minus 2 is equal to negative 3/4 times x minus 3. And they want you to approximate at 2.6. It's concave down, so we know it's going to overestimate again, isn't it? So it's going to be one of these. It won't be the underestimate. So we're just going to plug in 2.6. There's no calculator, so let me tell you how to deal with this when you got a fraction and a decimal. So you're going to have 2.6 minus 3. So first of all, just do the subtraction with the decimal and figure out if it's more beneficial to leave it as a decimal or if it's easy to convert it to a fraction. Because it might be, we know what 3/4 is as a decimal. What is that? But it might be easier to take the decimal you're going to get here in a second and turn that into a fraction. Okay, so we'll see here. So we're going to have y minus 2 equals, I forgot to add the 2 over. Let's add the 2 over. So y equals negative 3/4. This will be negative 0.4. Is that agreed? I do need the negative that time. So it's a negative 0.4 plus 2. What is 0.4 as a fraction? Is it easier to take 0.4 and turn it to a fraction or turn? I think so. What's 0.4 as a fraction? 2/5. So we're going to have negative 3/4 times negative 2/5 plus 2. All right, you'll have a negative times a negative, which is a positive. 2 goes into 2 once, 2 goes into 4 twice. So I'm going to get 3/10 plus 2. 3/10 plus 2 would be, what would that be as a common denominator? 20 tenths, and then, yes, it'll end up being 23 tenths. Do they give you fractions? What do they give you for answers? Oh, they don't give you decimal. So the answer is what? 2.3, and the answer is C because it overestimated. They gave you decimal still. Again, they give you a point, got the slope. The slope's negative 1.2 from the table because they said selected values of the derivative are given in the table. So we have the slope of the tangent line at 3. It's negative 1.2. We have the point is 317. So we're going to have y minus 17 is equal to negative 1.2 times x minus 3. They want you to estimate at 3.2. So I have y equals negative 1.2 times 3.2 minus 3 plus 17. Negative 1.2 times 0.2. Is that correct? Is that correct? All right, what's 12 times 2? 24, so it's going to be negative 0.24 because there's 2 decimals, correct? And then negative 0.24 plus 17 would be 16.76. The answer is A. Is this easy? Is this helping? Okay. Last one. I think the very last one's a little different, or maybe it's not. You got 4, you got your slope, you want to estimate at this, it's concave up, so it's going to underestimate this time. So it's going to be B or D. So we're going to have y minus 7, this is getting repetitive, 1/5 times x minus 4. We're going to plug in 3.5, so y minus 7, I do think a fraction is going to be way easier this time. 1/5, so you're going to have 3.5 minus 4. Well, I'm going to go ahead and put the plus 7. I'm going to add 7 to this. So I'm going to have 1/5 times a negative, 3.5 minus 4 is negative 0.5, which is negative 1/2, is it not? So that's going to give me negative 1/10 plus 70 over 10, which is going to be 69 over 10, which is 6.9. So the answer is definitely B. Is that easy? Last one. You got your point. All right, here it is. This is a different one. It says, let f be a function found. They give you the derivative, so I'll be able to find the slope of the tangent line. Let's just do that real quick. So dy dx at 1, negative 2 is going to be 1/2 times 1 minus 1/4 times negative 2 squared. So that's going to be 1/2 minus negative 2 squared is what? 4. So you're going to have 4 times a fourth. What will that give you? 1. So that's going to give me negative 1/2. So the slope of the tangent line is negative 1/2. It passes through the point 1, negative 2. So my tangent line equation would be y minus, or y plus 2 is equal to negative 1/2 times x minus 1. It's concave up, so you know it's going to, what is it going to do if it's concave up? Underestimate, so you can go ahead and get rid of over. All right. And you've got the interval from 1 to 1.5. Let k be the approximation for f of, okay, no, this is not. This is the same thing. They're just saying the answer is going to be k. So you're just going to plug 1.3 in. Never mind, it's the same thing. So it's going to be y equals negative 1/2 times 1.3 minus 1 minus 2, because I moved the 2 over. So you're going to have negative 1/2 times 0.3 minus 2. It's up to you. I guess maybe a decimal would be better this time. So negative 0.5. You can do 3/10 for 0.3, though, if you want. I'm just going to do a decimal this time, though. Because what's 5 times 3? 15. How many decimal places are there? 2. So it'd be negative. Did that help with the decimal stuff? And that's going to give you negative 2.15, and that's what k is. So the answer is going to be C. I do have time to do L'Hopital's. That was fast. Way faster than that related rate crap. Okay, related L'Hopital will be easy. You guys will be able to help me with this. All right, let f be the function. This is how they do L'Hopital's rule. Again, you need to check to make sure it's 0 over 0 or what? Infinity over infinity or negative infinity over negative infinity. We got f of x is this. Let g be a differentiable function whose derivative is this. And it is known that the limit as x approaches infinity of g of x is infinity. So we know the denominator is going to give you infinity. Let's check the numerator to see if L'Hopital's rule works. Well, this is 3x plus 2e to the negative 3x. When you approach infinity, remember it always has to behave according to what leads the dance. What leads the dance? The one with the highest power, or what did I tell you is the most powerful function in mathematics no matter what? I told you the other day when we did L'Hopital's rule, I told you what is the most powerful function in mathematics? E to the x, or any exponential function, 2 to the x, 3 to the x, e to the x. An exponential curve, a J curve or an L curve, there's nothing more powerful. Now, what is this? It's actually an L curve. Okay? So as x approaches infinity, you're actually going to be approaching, so as x approaches infinity, since it's an L curve, okay, since this is an L curve, hold on a second here. We got the limit as x approaches infinity of 3x plus 2e to the negative 3x. You can sit and work, but I got about 10 more minutes. So infinity, this is an L curve, and I'm approaching infinity. What does an L curve approach, though? 0. But what will this approach? Infinity. So it's still going to be infinity. Okay, so that's still infinity. So you got infinity over infinity, correct? So we can do L'Hopital's rule then. So they want you to find the value of the limit if you take f of x divided by g of x. So we're going to do the limit as x approaches infinity. Oh, gosh, guys. I screwed up with y'all on this one.
Why would you do that?
Yeah, this is so silly. I could have done this another way. Okay, we're going to do L'Hopital's rule, but I'm going to show you a better way to do it in a second. What's the derivative of the top? 3 minus 6e to the what? Negative 3x. Correct? And we know the derivative, sorry, this was supposed to be g of x. And the equation they give you is actually not g, it's what? That's actually g prime. So you keep it the same. 4 plus 1 over x. I think this is pointless. I'll tell you why in a minute. Because when you do the derivative of this, you can do the derivative term by term on top. Okay, so when you do the limit, you can just use limit properties. What's the limit of a constant? So that's 3 minus, what's the limit of the L curve? 0. Over, what's the limit of a constant? Constant. And what's the limit of this when it's bottom heavy? So what's 1 over x going to be if it's bottom heavy?
Small bottom.
No, if it's bottom heavy and you're approaching infinity. 0. So you're going to have, what's the answer going to be? 3/4. I think you could have done that. No, you couldn't have done it from the original equation. You needed L'Hopital's rule because I don't know what g of x is. I did not know what g of x is. So you had to do the L'Hopital's rule to get to the first derivative. Okay?
Oh, I have a question. For this, you take out.
Take out a 9.
Do you put that right
You
here?
can just put it right there and it's multiplication. It's all multiplication.
Okay.
That'll
So then
be-
do you just times these together then?
Mm-hmm.
Okay.
Yep.
Okay.
You can put that 6 out
Can
there.
I take that quiz today, right now? Because I'll be on.
Uh,
Or do you want me to wait?
I need about 9 more minutes
All right.
because I'm finishing this and then I can, if you come back 9 minutes, I'll print it for you. All right, number 2. This one right here is going to give you, does it give you 0 over 0? Yeah, it definitely gives you 0 over 0. So let's do L'Hopital's rule. And the reason I know it's 0 on bottom, what's e to the 0 power, everybody? 1. What's 2 times 1? What's 2 minus 1? What's the natural log of 1? 0. So definitely 0 over 0. So we got the limit as t approaches 0. Let's do L'Hopital's rule. So we got the limit as t approaches 0. It'll be cosine t on top over, this is going to be 1 over 2e to the t minus 1 times the derivative of 2e to the t minus 1, which will just be what?
2e to the t.
Yeah. Now I'm just going to plug in 0 and see what happens. I bet the answer is going to be like, it's either going to be 0 or 1/2. I can just tell. What's the top? What's the cosine of 0? 1. Okay, now I know it's going to be 1/2. All right, and then if you plug in 0 on bottom, you get e to the 0, which is what? 1. What's 2 minus 1? So that'll be 1. That fraction will be 1. Times, this will end up being e to the 0 is 1, 2 times, that's 2. So the answer is going to be limit of a constant's a constant. The answer is 1/2.
Hi, Morris. Did you remember I asked you about the...
Yeah, I'll go over it with you today.
Okay, thanks.
Okay? All right, this one, if we plug in pi over 2, cosine of pi over 2 is 0, is it not? So that's going to give you 0 over 2 times pi over 2 is 2 pi. No, or it's just pi. Pi minus pi. Is that 0 is 2? So L'Hopital's rule works. So we're going to have the limit as x approaches pi over 2 of -3 sine x over just 2, right? Is that right? Yeah. So we're going to have -3 times sine of pi over 2, do my direct substitution, divided by 2. What's sine of pi over 2 up here? What's sine? Sine is the y. So what's sine of pi over 2? 1. So we're going to have -3 times 1 is -3, so it'll be -3/2. The answer is A. All right, I want to explain this second time around a little bit better. Okay, so this is f of x is given to this. Let me explain the derivative of this, or the limit of this. The limit as x approaches infinity of f of x. Let's do f of x. It's 2x plus 3e to the -5x. So this is a polynomial. This is an exponential. You have to do those separate. You have to do, because you're adding 2 different functions. So you can't do this. This is not like a polynomial where you can just delete all the other terms. Okay, so I kind of explained that wrong on number 1, and I realized that we're taking a polynomial plus an exponential. So you just have to do it derivative term by term. Okay, so when we're doing, or not derivative, we have to do the limit term by term. So when you do the limit of this as it approaches infinity, it'll be what? Plus, and what's the limit as x approaches infinity of the L curve? Think about the L curve. As it approaches infinity, what is it approaching down here? 0. So you got infinity plus 0, which is infinity. So this top is approaching infinity. They already told you g of x is approaching infinity, so does L'Hopital's rule apply? So then we can take the limit as x approaches infinity of f of x, which is 2x plus 3e to the -5x, over g of x, because they don't tell us what g of x is. I can do L'Hopital's rule. So L'Hopital's rule is going to be 2 plus negative 15 e to the negative 5x, because the derivative of e to the negative 5x is e to the negative 5x times a negative 5. I'm almost done. And then over g prime of x. Now, g prime of x is what?
1 over x plus 4 cosine.
So we have 2, I could put 2 minus, could I not? 2 minus 15 e to the negative 5x. We know what g prime of x is. It's 1 over x plus 4 cosine of 5 over x. Now watch how I do this, because I'm doing limit properties. I can do the limit of a sum, a difference, a quotient. You're allowed to do the limit of a sum, a difference, a quotient, and a product. You just do it term by term. All right, first of all, what's the limit of a constant? 2. What's the limit of this going to be as you approach infinity? 0. What's the limit of this? It's going to be bottom heavy, right? So that's 0 plus. Now this is interesting, because when you plug in here, this is bottom heavy, so that ends up being what? What's cosine of 0? 1, and then 1 times 4 is what? So you get 2/4, which is 1/2.
I'm gonna be gone Wednesday, Thursday, Friday, and Monday and Tuesday.
Not today though, right?
No.
I'll go over it in
Is there
class.
any work like I can do over the weekend?
Yeah, I'll give it to you in class today. Because I got you 5th hour, I can do it. Or 4th hour, I can just go over it with you. This in L'Hopital's rule, blah, blah, blah. I'm just going to assume it's 0 over 0 because it's been 0 over 0 every time. All right, so 6e to the 4x. What's that going to be? 24e to the 4x minus 6e to the 3x over 2 cosine 2x. So I did my derivatives pretty quick there. Plug in 0. E to the 0 is 1, so that's just going to be 24 minus 6 over, what's cosine of 0? 1, so that'll just be a 2. So we're going to have 24 minus 6 is 18. 18 divided by 2 is what? 9. Answer C. And last one. Can we assume it's 0 over 0 again? Or do you need me to check it? Oh, let's check it. All right, let's plug in pi. Pi squared minus pi squared is going to be 0, so we definitely get a 0 on bottom. What's secant of pi? Well, secant is really 1 over cosine, so it's 1 over cosine of pi. What's cosine of pi? -1, so it'd be -1. All right, so that's going to give you -1 times pi, and then if you plug in pi here, are you going to end up with pi minus pi? So it is 0 over 0. So you can go ahead and cross out the non-existent then in the multiple choice. You know it can't be that. So then we're going to have the limit as x approaches pi. L'Hopital's rule, do the derivative of the top. It's 1 plus pi. What's the derivative of secant? Secant x, tangent x. Over, what's the derivative of the bottom? 2x. Plug in pi, you're going to get 2 pi on bottom. Plug in pi on top, you're going to have 1 plus pi times secant of pi and tangent of pi. All right, help me out here. Little unit circle work. 1 plus pi. What's secant of pi? It'd be 1 over cosine of pi. Cosine is pi of what?
-1.
So 1 over -1 is going to be -1. So secant of pi is -1. What's tangent of pi?
I'd assume that's 0.
Yeah, because it's sine over cosine. 0 divided by -1 is 0. Guess what's going to happen to that part? This part's going to 0 out. Correct? So you're going to get 1 over what? 2 pi. The answer is 1 over 2 pi. Man, that was really helpful.